So problem 117 is an interesting problem in that we're basically working in in 3 dimensions now, which just means that we're going to wind up with more equations. And what we have is basically a wooden frame structure that has a load acting on it, and then it's also supported by some blocks. And again, you can see it in the book, but again, we have a bunch of points A through H, and I've defined them relative to A being the origin. So we can go through and define all the important points in the structure. And then what we're told is that there's only vertical loads acting. So we only have, and I'm going to say Z is the vertical direction. So out of the perpendicular to the ground. And so we have one component, and each of the loads at any one of these points, we have one component, and that's in the Z direction. And then at point F, we also have our load acting. So we need to subtract P, which is our load from that, from the internal force. And so what we need to do then is we also have some moments acting. And because if we do our force and moment balances, we're gonna get one non-trivial equation for the force balance because we only have components in the Z direction. But we'll get 2 non-trivial equations for our moment balance. But we have, let's see here, in the forces unknown, we have 1, 2, 3, 4, 5, 6, 7, 8. But now we'd only get 6 equations if we looked at 2 of these. If we looked at 3 of them, we would get 12 equations. So again, at 3 different members, we'd get 12 equations, right? If we looked at 4 different members, we'd get 12 equations. So we can either get 9, where we'd have too many, or 12, where we'd have too few. But then we can say, well, there must be some moments acting at some of these junctions. So I assume that there was a moment acting, basically no twisting moment, just a bending moment. So at point B, there'd only be a moment in the X direction, and point C, there'd only be a moment in the Y direction. All right. So we have these forces and moments acting, and so now we can see we have 8 forces and 4 moments, and that gives us the right number of unknowns for the number of equations we have. So let's see here. Okay, yep. And so we can go through and we can just crank through this analysis. Again, it's a bunch of algebra. There's 12 equations and 12 unknowns. I looked at I took 4 different sets of free body diagram. Free body diagram for the entire structure. So we have loads A, D, E, H, and then the external load at F. And then I looked at the internal moments, the moments created by all those forces, and also the moments created for, at the junctures. Then I looked at A, B, F, which is one of the bars. And then I looked at B, D, C, or BCD, and remembering that B I've used before as an internal load, so I need to put a minus sign in front of one of these. And then I looked at CGH, and again, C, one of these has to have a minus sign in the summation. So I wound up with a set of 12 equations and 12 unknowns. Now it turns out that all the moments are 0. I suppose we could have assumed that to begin with, but we would have then had some redundant equations that would have just been trivially satisfied, but it's hard to know that to begin with. they basically said to just assume that there's vertical loads at each of the junctures, but again, it wasn't clear if they meant that there were also no moments there. But it turns out that the moments are all zero. So we get all of these loads on our structure, and we actually would just ask to find A, D, E, and H, which is where they're connected to the footings. So 1/15 of the load is carried by footing A. Footing B carries 2/15 of the load. Footing E carries 8/15 of the load, and footing H carries 4/15 of the load. And this makes sense because the load is closer to E and H, so there's going to be more of it being carried by those than by D and A.